To create a hexagon grid system in the flat top orientation, first create a blueprint actor and add a single component called instance static mesh. Next, create variables to store the 2 radii and 2 diameters of a hexagon. We also need variables to store the height and width of our hexagon grid, as well as the row offset so the hexagon slot evenly with each row or column. Create a variable to store the static mesh of the hexagon you'll be using, and make sure that the flat side of the hexagon is oriented along the x-axis. Optionally, create variables to store offset and scale values if you want to adjust the grid spacing. Make sure to set the scale value to greater than 0 so your grid will at least show up. Now create 4 functions called calculate sizes, vertical space, horizontal space, and offset hexagons. The calculate sizes function should take the static mesh variable and get the bounding box values from it. You will need to split the pins until you have access to the max x and max y values and multiply these against your scale variable. Then pass the x result to your small radius and your y result to the large radius. You can multiply the radii by 2 to get the 2 diameters. The vertical space function should take the width value and multiply that against the square root of 3 multiplied against the large radius. You can then add this to the result of the width value multiplied against the offset and pass the result to the output pin of the function. The horizontal function should take the height value and multiply it against the large diameter multiplied against 3/4 or 0.75. Then add this to the result of the height value multiplied against the offset and pass the result to the output pin of the function. Next, your offset hexagon function should simply take the small radius and multiply it against -1 and set that as the row offset variable value. Finally, we can write our construction script. It should use the setStaticMesh node and target the instance static mesh component we created earlier. We can pass the static mesh variable into the new mesh pin, then call the calculate sizes function to populate our radii and diameters. Then call our first for loop with the index starting at 0 and ending at the height value. Then call the horizontal space function into our second for loop, which will start at 0, but this time end at the width value. Pull this into the vertical space function and then add into the add instance node. Split the transform pin to have access to the x and y values. The vertical space return value will go into the x value. Make sure to add your offset in as well. The horizontal space return value will feed directly into the y value, and then pass your scale into the add instance node as well. On the second for loop, pull off the completed pin into a flip-flop node, with A going into the offset hexagon function, and B going into a setter node for the row offset value, which should equal 0. And just like that, you have completed hexagon grid system in the flat top orientation style. Enjoy!